hearing loss due to noise exposure has been added to the long list of occupational health and safety problems confronting many industries today. Noise is any loud sound that is intrusive, irritating, or undesired. It has been long known by both doctors and workmen that prolonged exposure to loud noise produces deafness. But only recently has industry seriously recognized it as a crucial health and accident hazard. Loud sound that is intrusive, irritating, or undesired. It has been long known by both doctors and workmen that prolonged exposure to loud noise produces deafness. But only recently has industry seriously recognized it as a crucial health and accident hazard. Noise can become a very real accident hazard if the level or loudness is sufficiently high to interfere with speech reception, voice signals, or the transmission of instructions or other auditory signals. Noise can distract a man at his job, and it can drown out or mask warning signs. Hearing is the special sense by which noises and tones are received as stimuli. In the process of hearing, airborne sound waves are collected by the external ear and conducted through the auditory canal to the eardrum. At the eardrum, the pressure variations of sound in air are transformed into very minute mechanical vibrations that are then transmitted by three bones of the middle ear, the hammer, anvil, and stirrup, to the oval window. The movement of the oval window sets up wave motions in the fluid of the inner ear, which are sensed by the hair cells in the cochlea. The compression, tension, and bending of these hairs transforms the mechanical sound vibrations into electrical impulses. These impulses are then transmitted by the acoustic nerve to the brain. Transformation of sound to electrical nerve flow is largely dependent upon the hair cells. Considering the minute size of the hair receptor, it can be easily understood that if the amplitude of the vascular brain vibrations becomes too large, as induced by excessive noise, the resultant severe mechanical stresses cause the hair cells or their bristles to fatigue, lose their resiliency, and their ability to return to their normal position. This gives way to deterioration or monocellular decay, or in other words, a gradual loss of hearing as the result of destruction of structures in the inner ear. As we grow older, our ears gradually become less sensitive to sound. This normal loss of hearing due to aging is called presbycusis.
Hey, John, watch out, look for the car.
Permanent loss of hearing due to excessive exposure to noise is greater than that which results from aging. Various factors contribute to noise-induced hearing loss. One is the overall noise level. Another is the composition of the noise, its frequency, tone, or impact. A third factor is the duration, frequency, and distribution of noise exposure during a typical workday, and total exposure time during a work life. And fourth is the susceptibility and sensitivity of the individual ear itself. Some people may have more sensitive or tender ears than others, and may more easily incur some degree of hearing loss. There is little doubt that a major cause of hearing loss today is overexposure to excessive noise. But there is a difference in noises. For example, even though two different noises may have the same overall loudness, intensity, or sound pressure level, their compositions or spectrums may differ to such an extent that one of them may produce a permanent hearing impairment while the other may not. The reason for this is frequency, or pitch. At the higher frequencies, human hearing is most sensitive and most susceptible to damage when subjected to excessive noise. The low-frequency noise we can tolerate because our ears naturally discriminate against low-frequency sounds. Most beginning noise-induced hearing losses occur at frequencies above the normal speech frequencies. Therefore, it is vital to control higher frequency noises because the first indication of hearing loss, which can be expected at around 4,000 cycles, is quickly followed by noise-induced hearing losses in the lower speech-important frequencies. Generally, the louder the noise and the longer the ear is exposed to it, the greater the hearing loss. According to current medical opinion, noise energy having predominant frequencies above 500 cycles per second are a greater potential for causing hearing loss than noise in the low frequency region. In addition, it is believed that intermittent exposures are far less damaging to the ear than continuous exposures, even if the intermittent sound pressure levels are considerably higher. An extremely loud noise may rupture the eardrum or destroy the ossicular chain, but such catastrophic noises are usually predictable, and we can prepare for them. In order to control noise exposure, accurate information defining the extent, duration, and distribution of noise exposure at the work site is needed. To measure noise or sound levels, an approved and acoustically calibrated sound level meter is used. The sound pressure level, or intensity of the sound measured, is expressed in decibels, dB, which is a unit for indicating the relative loudness of sound. The range of loudness ordinarily detectable by the human ear starts at 1 dB for the faintest audible sound and extends to around 115 dB for the loudest permissible sound. Present noise standards set by the Walsh-Healy Act permit 8 hours of exposure at 90 decibels and shorter periods of time at louder levels, up to 115 decibels. Total duration of exposure allowed at 115 decibels, though, is only 15 minutes. Another device designated to measure the total noise to which a worker is exposed for a workday is the noise dosimeter. Exposure throughout the day is recorded on a memory cell. At the end of the shift, the dosimeter is inserted into a readout device. The worker's daily noise exposure is then displayed as a percentage of the allowable limit established by the noise standards. The memory cell is automatically cleaned for reuse as the exposure information is retrieved. Different occupations in mining expose individuals to different ranges of sound levels. example, men riding man trips are exposed to sound levels ranging from 74 to 100 decibels. Shuttle car operators are subjected to sound levels of 90 to 98 decibels when loading, and 85 to 92 decibels when tramming. A cutting machine operator is exposed to sound levels ranging from 93 to 98 decibels when sumping in. Continuous mining operations produce sound levels of 89 to 107 decibels during the cutting and loading cycle. Loading machine operator is exposed to sound levels ranging from 90 to 108 decibels. And a pneumatic roof bolter produces sound levels between 104 to 118 decibels when drilling. Surveys disclose that several underground coal mine occupations exposed workmen to sound levels that resulted in shift noise exposures above the maximum allowable level established by the Walsh-Healy Act. This confirmed earlier suspicions that a noise problem did exist in underground coal mining. But what can be done about the problem once noise measurements have been made? When employees are subjected to sound levels exceeding those listed in the table of permissible noise exposure, then an effective hearing conservation program must be provided by the mine operator. Feasible engineering or administrative controls must be utilized, or personal protective equipment must be made available to workers. Underground mining seldom lends itself readily to the adaptation of materials or methods necessary for noise abatement, either at the noise source or in the hearing zone of the worker. But noise reduction by engineering control procedures can be accomplished in many instances. For example, reducing the sound intensity at the noise source might be accomplished by substituting quieter equipment, such as using a rotary drill in place of a star drill and air hammer type. Or if air-operated machinery is used, appreciable reduction of sound can be achieved by muffling the exhaust of the machine or by piping the exhaust to a distance where the noise is not objectionable. Most mining equipment was not designed with noise suppression as one of the prime considerations. Therefore, when new equipment is ordered, complete noise level specifications should be furnished to manufacturers. The Bureau of Mines is cooperating with manufacturers in developing and testing quieter operating mining machinery. Maintenance is another important element in noise control. By replacing or adjusting round and loose or unbalanced parts, keeping tools properly sharpened and cleaned, and by efficiently using lubricants and cutting oils, existing machinery can be kept in quieter operating condition. Controlling noise at the source is the ideal means of preventing noise-induced hearing loss. But if noise cannot be reduced to permissible intensities through engineering controls, then administrative controls should be developed to limit duration of workers' exposure. This method involves arranging work schedules or rotating personnel to reduce the amount of time spent in noisy areas. Employees working the major portion of a day at 90 decibels or above and who have reached the upper limit of duration for a high noise level should be rotated to work the remainder of the day in an environment with a noise level well below 90 decibels. Remote control TV cameras can be used to reduce the time of noise exposure by allowing operations to be monitored away from the noise-producing areas. When both engineering and administrative controls fail to reduce noise or duration of workers' exposure below the permissible levels, the use of personal protective equipment is advisable. When necessary, mine operators must supply such equipment, and employees must be instructed in its use and encouraged to wear it.
This way, and they have a top and a bottom. That's the only thing you really have to remember. Get that top up so that the band goes behind the head, and that keeps it away from your lamp cord.
Use and encouraged to wear it.
This way, and they have a top and a bottom. That's the only thing you really have to remember. Get that top up so that the band goes behind the head, and that keeps it away from your lamp cord and your hard hat. Then try those on. They go on that way, top up. Once you get it on, you push in the back so it's nice and tight as you can have it on. Feel good? It's fine. Fine.
Although occupational noise exposure regulations presently require both provision and use of personal protective equipment, its use is considered by most acoustical experts to be only an interim measure, while engineering and administrative controls are being perfected. Another important aspect of a hearing conservation program is pre-employment audiometric hearing tests for employees.
You are going to hear some sounds. Some will be high and some will be low, but most of them will be very faint.
These tests provide a guide for placing new employees. Early detection of a hearing problem will avoid putting a man on a job where he may be exposed to excessive noise or where he may not be able to hear warning signals or instructions. This may prevent a tragic and costly accident.
Do you hear better in one ear than the other? All right, let's begin.
Periodic checkups or follow-up audiograms to detect changes in the status of an individual's hearing should be conducted as prescribed by the company physician. The determination of the extent of hearing loss involved rests finally with the physician. Follow-up tests can also be used to assess the effectiveness of the noise control program. Most hearing losses develop gradually. No pain is involved, nor is there much interference with communication. An individual may not realize his hearing is being impaired.
Mr. Feitler? Mr. Feitler?
He doesn't get used to noise. He just hears less of it. If necessary steps are not taken, the deterioration of hearing soon becomes permanent. Any meager compensation payment cannot offset the hardship of hearing loss to an otherwise healthy person. The effectiveness of a hearing conservation program depends upon the cooperation of employers, employees, and others concerned. It is management's responsibility to conduct noise measurements and surveys, initiate noise control programs, inform employees of the benefits to be derived from a hearing conservation program, and provide hearing protection equipment in areas where it is recommended. It is up to the employee to make proper use of the equipment provided by management and to observe any rules or regulations in the use of this equipment to minimize the noise level exposure. The importance of this responsibility is expressed more explicitly by Section 206 of the Federal Coal Mine Health and Safety Act of 1969. which states, on and after the operative date of this title, the standards on noise prescribed under the Walsh-Healy Public Contracts Act, as amended, in effect October 1st, 1969, shall be applicable to each coal mine, and each operator of such mine shall comply with them.